In this video, I will explain lossless lines. Lossless line. A signal that is being transmitted through a practical transmission line can suffer from losses due to various factors. First one is copper loss. Copper losses. Second one is dielectric loss. Dielectric losses. Copper losses. Second one is dielectric losses. Third one is radiation and inductance losses. Copper loss. Copper loss. These losses are due to dissipation of energy in the form of heat by the current flow through the conductors. This one is a pair of conductors. Conductors which are used to transmit the information, the signals from one point to another point. Whenever a current is passing through that conductor, some heat is produced. These copper losses. These losses are due to dissipation of energy in the form of heat by the current flow through the conductors. Second one is dielectric losses. These losses are due to the heating effect on the dielectric material between the conductors. This is the transmission line. Some dielectric material is available between these two transmission lines. It acts as a capacitor. Sometimes some dielectric losses are also there. These losses are due to the heating effect on the dielectric material. This one is dielectric material. Heating effect on dielectric material between the conductors. Next one is radiation and induction losses. Radiation. Basically, these losses are caused by the fields surrounding the conductors. Induction losses occurs when the electromagnetic fields about a conductor cuts through any nearby metallic objects and a current is induced in that object. That is called as induction loss. Radiation loss. Radiation losses occurs because some magnetic lines of force about a conductor do not return to the conductor when this cycle alternates. Do not terminate. Therefore, these are the losses which are observed on the transmission lines. Lossless line. These are some losses. Lossless line. A transmission line. While designing a transmission line, the loss of the transmission line must be minimized to prevent loss of information. While designing a transmission line, the loss of the transmission line must be minimized to prevent loss of information. A transmission line is said to be lossless when conductor of the line are perfect, that is conductivity is infinity. Lossless means ideal cases. any conductor having some conductivity that is represented with sigma, the sigma must be infinity. The dielectric medium between the conductor has zero conductivity, that is sigma d is equal to 0. A transmission line is said to be lossless when first one, conductors of the line are perfect, that is sigma c is equal to 0. C means conductors. Second one is the dielectric medium between the conductors has zero conductivity. That is sigma d is equal to 0. For lossless transmission line, by substituting sigma c is equal to 0 and sigma d is equal to 0, sigma d is equal to 0, sigma c is equal to infinity and sigma d is equal to 0 in distributed parameters of various kinds of transmission lines, it is evident that R equal to 0 and G equal to 0. First one here, gamma is equal to square root of R plus J omega L G plus J omega C. That is equal to alpha plus J beta, where gamma is called as the propagation constant of the wave. Propagation constant. Substituting R is equal to 0 and G is equal to 0 in the above equation. Gamma is equal to square root of J omega L into J omega C. That is J omega root over L that is equal to alpha plus J beta. Compare the real and imaginary parts here. 0 plus J omega root over LC. Alpha is equal to 0. Beta is equal to omega root LC. Therefore, propagation constant gamma is equal to J beta. Propagation constant gamma is equal to J beta. J beta is equal to omega root over LC. Second one is phase velocity. Phase velocity is U, that is equal to omega by beta. Omega by beta is here beta is omega root over LC. That is equal to 1 by root over LC. Characteristic impedance. Third one is characteristic impedance. Characteristic impedance Z0 is equal to square root of R plus J omega L by G plus J omega C. R is equal to 0, G equal to 0, J omega L by J omega C. That is equal to root over L by C. The phase velocity, that means VP and U, and the characteristic impedance Z0 are independent of frequency and depend on its distributed line parameters. Z0 depends on distributed line parameters and independent of frequency. Phase velocity is also depends on distributed values parameters L and C independent of frequency. Distribution per in distributed parameters of various kinds of transmission line, it is evident that R is equal to 0 and G is equal to 0. There is no losses on the transmission line. The series element R is equal to 0 and shunt conductance G is equal to 0. With this, the analysis of lossless line is completed.